So on assignment number 2, we're going to move into still simplifying radicals, but we're going to be multiplying radicals together and then simplifying. So we're going to be simplifying products that involve radicals. Let's go ahead and get started. So let's review a little bit, start with a review of what we did yesterday. We have the square root of 40, which we can write as the square root of 4 times the square root of 10, and we chose the square root of 4 because that's a perfect square. The square root of 4 we know is 2. So we can write the square root of 40 as 2 radical 10. We can do the same thing with number 2, except this is a variable. We have x to the 7th. We know that the x's can be pulled out in pairs. The question is, how many pairs are there if we have 7 x's? Well, there's 3 pairs. And then we have one x that's left over that doesn't have a buddy to go out with. And so it's just x to the 3rd times the square root of x. I'm going to have you take a look at 3 and 4, and we're going to get into a little bit more with where we're going today. Still review though, number 3, let's take a look at the number part first, the square root of 20. We know that that is 4 times 5. And the square root of 4 we know is 2. That's going to be outside of the radical. But the 5 we can't take outside of the radical. Then we also have the x to the 4th. Well, how many pairs is that? That's 2 pairs, which would be on the outside of the radical. So this simplified would just be 2x squared times the square root of 5. Take a look at number 4. The difference now with number 4 is that we already have a number on the outside of the radical. So whatever we pull on the outside, we're going to have to multiply by 3. So what's a perfect square that goes into 24? Well, we can say that's 4 times 6. And the reason I chose 4 and 6 instead of like 3 and 8 is because I know that the square root of 4, well, that's 2. So we have the 2 times the 3 on the outside. That gives us a 6 on the outside. I also have this 6 that I can't pull out because I don't know what the square root of 6 is. So that's the number, but then I still have the x to the 5th. There are 5 x's there. Well, that's 2 pairs of x's, plus I have one x that I can't pull out that stays inside the radical, and my simplified answer is 6x squared times the square root of 6x. So I'm going to have you try this one on your own. Go ahead and pause the video and then see if you can simplify number 5 completely on your own. Hopefully you were able to do that, and hopefully you were able to do this. This is 25 times 5 is 125, and the square root of 25 we know is 5. So that's on the outside along with the 7, and if I multiply those together, that's going to give us 35 on the outside. And then we have this radical 5 that's going to have to stay inside the radical sign. Well, then I'm going to take a look at my x's. There's an x squared there. I'm going to pull them outside of the radical. There's 1 pair. And I have y to the 5th. That's 2 pairs of y's that I can pull out, and 1 y that has to remain inside the radical. And so my simplified expression is going to be 35xy squared times the square root of 5y. So let's take a look at another one. Here is now where we're going where we haven't gone before. We can do this 2 different ways. We can take the square root of 4, which is 2, and we can take the square root of 3, which is, or the square root of 9, which is 3, and multiply those together and get 6. The other thing, though, that we can do is we can actually take these 2 numbers and multiply them together. If they're both in the radical sign, we can multiply the 4 times the 9 and get 36, and it's still inside the radical sign. And we know that the square root of 36 is 6. What that tells us is that if we have 2 numbers that are inside a radical sign, we can multiply those 2 numbers together to get a bigger number inside the radical sign that can be simplified. Let's apply that here to number 7. What I'm going to do is, there's 2 things that I can do here, 2 ways I can solve this. First, I can take the square root of 10, which I can't simplify. I can take the square root of 300, which I can write as the square root of 100 times the square root of 3. Well, the square root of 100, I know that that is 10 on the outside. But then the square root of 10 and the square root of 3 I can't simplify, but I can multiply them together. The square root of 10 times the square root of 3 is the square root of 30. And so my final answer would be 10 radical 30. Now the other way that I can get the same answer is I can just multiply these together right away. 10 times 300 is the square root of 3,000. Well, is there a perfect square that goes into 3,000? Well, I could write it as 100 times 30 is 3,000. The square root of 100 I know is 10, and then the square root of 30 I don't know, and there isn't a perfect square that goes into 30, so that would give me 10 radical 30. Both ways were able to give me the same answer. So let's keep going with a few more of these. Square root of 15 and the square root of 3, you can tell right away that there isn't a perfect square that goes into 15, and there isn't a perfect square that goes into 3. I can't simplify this. But if I multiply them together, 15 times 3 is 45. Now, is there a perfect square that goes into 45? And yes, there is. It's 9 times 5. And the square root of 9, we know, is 3. So the 5, we can't take the square root of, so that's going to stay inside the radical sign. So it's going to be it's going to be 3 times the square root of 5. If we try number 9, two ways that I can do number 9. I could simplify both of them first. I could take the square root of 8 and write it as the square root of 4 times the square root of 2. The square root of 4 we know is 2, and I can't do anything with the radical because I don't know what the square root of 2 is. I can also do this by taking the square root of 12 and writing it as 4 times 3. The square root of 4 we know is 2, and I can't do anything with the radical 3. But I'm multiplying these two things together. The square root of 8 simplifies to 2 radical 2. The square root of 12 simplifies to 2 radical 3. So if I multiply the things on the outside together, that's 2 times 2, which is 4. And 2 times 3 inside the radical is going to give me a radical 6. And I have an answer of 4 radical 6. Now the other way that I could have done this is I could have actually multiplied 8 times 12. 8 times 12 is 96. And then I'm going to try to figure out if there is a perfect square that goes into 96. And the biggest perfect square would be 16. But let's say that I didn't know that 16 went into 96. I could write this as 4. I think 4 goes into 96. And 4 goes into 96, I believe, 24 times. So this would be 4 times 24. Well, we know that the square root of 4 is 2 times the square root of 24. But is there a perfect square that goes into 24? And the answer to that would be yes. Square root of 24 is 4 times 6. And so the square root of 4, that also becomes a 2. And so I have this 2 on the outside and this second 2. 2 times 2, if I multiply them together, I get 4. And then I have this radical 6 that I can't do anything with. And so you can see if I multiply them together first, it still simplifies to 4 radical 6. Two more questions here that I'd like for us to try together that not only involve the square roots of numbers, but involve the square roots of variables. And so let's start with the first one. I have the 5 on the outside, but I'm going to just go ahead and multiply the things on the inside of the radical sign together first. I have the 3 times the 6, which is 18, and x times x is x squared. So now I'm going to simplify the square root of 18, x squared. The square root of 18 does have a perfect square that goes into it, and that is 9. 9 times 2 is 18, and the square root of 9 is 3. So I have this 3 on the outside and this 5 on the outside. If I multiply those two together, I get 15 on the outside, and I have 2 on the inside. Then I also have this x squared, and that's 2 x's, so I can pull that on the outside, and my final answer is 15x times the square root of 2. If I move on to number 11, the last one here, I'm going to start by multiplying everything together that I can multiply together. For example, I can multiply the numbers that are on the outside of the radical together. 2 times the 6 gives me 12. And I can multiply the things on the inside of the radical together. 5 times 10 gives me 50. And n squared times n to the third. If I multiply like bases, I add the exponents. That's going to be n to the 5th. So now I'm going to simplify this expression. 12 is already on the outside, but the square root of 50 I can take and write it as 25 times 2. And the square root of 25, well, that is 5. And so I can take my 5, which is on the outside, times 12, which is on the outside, and that's 60 on the outside. plus I have this 2 that's on the inside. Then I have 5 n's, and I can pull 2 pairs out, so that's going to be n squared on the outside, and I have 1 n left over on the inside of my radical. So my final answer is going to be 60n squared times the square root of 2n. And this is what our homework assignment is going to be on today. So do your best on that. We can go over questions that you have tomorrow in class.